All right, everybody, we're starting chapter 6 today, so we're going to be on page 2 and 3 of the student note packet in the chapter 6 section, which is the yellow page section. So you're skipping all of those green pages because those were double from the exponential unit. So page 2 of chapter 6 student note packet, we're looking at angles and their measures today, and then we will move on. So chapter 6 is the last unit of the whole semester, and this is all about trig. So it should all hopefully be a review from Algebra 2, and then we'll kind of add to that as we go. So if we're looking back at geometry, what we know about angles and a ray, if we've got a ray, we put two of them together. One we call the initial side, and the other we call the terminal side. We've created an angle. Now, an angle in standard position is an angle whose vertex is at the origin, whose initial side is along the positive x-axis, and then we measure that angle counterclockwise from the x-axis if we're counting a positive angle, or clockwise if we're counting a negative angle. So this is at the top of page 2 of your student note packet. We're going to be talking about standard position. That becomes really important when we start looking at the unit circle. The vertex is at the origin. We measure positive angles starting from the positive x-axis going counterclockwise. Okay, so two commonly used measures for angles are degrees and radians. So we're going to talk about degrees first. The angle formed by one revolution is 360 degrees, is a full circle here. We'll always note degrees with a degree symbol because that's how we're going to distinguish between degrees and radians. A right angle, if we think back to geometry, is 90 degrees. Let me first graph 360. So remember, we measure from the positive x-axis. So the positive x-axis going counterclockwise is going to get us a positive angle measure. So that would be how we note 360 degrees. Okay, think back to geometry. A right angle is 90 degrees or a quarter of a revolution. It's a quarter of the way around the circle. If I want to draw 90 degrees, we start at the positive x-axis. We go counterclockwise like that. A straight angle is the angle that is 180 degrees. Just gives us a straight line. That's half a revolution, half a full circle. Again, we're going to start at the positive x-axis. We're going to go counterclockwise to measure a positive angle measure, and that would be how we denote 180 degrees. All right, so examples of angles in standard position. Let's just practice drawing these angles. The vertex is always at the origin. We always start along the positive x-axis. To measure a positive angle, we're going to go counterclockwise from that positive x-axis. If negative, then we'll go clockwise. So 57 degrees. I'm not going to be like super picky about diagrams like this, but I would say you want it in the right quadrant, of course, and then also in the right half of each quadrant. So 57 degrees, 45 degrees is halfway in the middle of the first quadrant, which means 57 degrees should be a little bit more than halfway. So we want to make sure that you guys are just kind of in the general right area, but 57 degrees is going to be that angle, and I'm just going to draw a line that denotes 57 degrees. Okay, 133 degrees, if we think about that, well, we can break 133 up into 90 degrees plus 43. So 90 degrees is the positive y-axis, and then we're going to add 43 more. Now 43 more is going to put us almost exactly halfway into the second quadrant, and that's how I'm going to mark 133 degrees. Now we get into a negative angle measure. So anytime we're measuring an angle with a negative value, we're just going to start along the positive x-axis, but this time we're going to measure clockwise instead. So we're going negative 251. Well, if I think about negative 251, that's the same thing as saying negative 180, which is a straight angle, plus another negative 71. So negative 180 puts us right here along the negative x-axis. If I add another negative 71 degrees to that, that's going to put us over halfway through that second quadrant if we're going backwards like that. So that's how I'm going to denote negative 251. And then 560 degrees, well, if we think about 560, that's 360. That's a full revolution plus another 200 degrees. So we're measuring positively, so we're going to start along the positive x-axis here. I'm going to go counterclockwise. This is 360. Another 200, that's another 180. Another 200 is 20 degrees more than 180. So this is how I'm going to note that 560 degrees. My spiral is going to go around the circle more than once because we have a full revolution plus another 200 degrees there. All right, so just practice drawing those angles. Just sketch an X and a Y axis really quickly in the homework, and then just draw your angle that way. Okay, so angles can be measured in degrees, minutes, and seconds. And the way that we use degrees, minutes, and seconds is if you guys ever look at a map and look at the latitude and longitude of maps, that's how those numbers are measured. So we have this example, 270 degrees, 31 minutes, and 49 seconds. It's not something that's super common. Most of the time through most of this unit and next semester during trig, we'll use just decimal values of degrees. But I just want you guys to be familiar with this different type of representation of angle measures. And so we're going to convert. So 31 minutes, if I want to convert 207 degrees, 31 minutes, and 49 seconds back into an actual decimal that we can use. 31 minutes is 31 over 60 degrees. We're just dividing everything by 60. To get from minutes to degrees, take the number of minutes, divide by 60. And then 49 seconds, if we want to turn that into minutes first, that's 49 over 60 minutes. And then to go from minutes to degrees, then we're going to have 49 over 60 times 60, or 3,600 degrees. All right, so in total then, if I want to add everything up and represent 207 degrees, 31 minutes, and 49 seconds as an actual decimal value, then we're just going to take all of those values as fractions, add them together to get this decimal here. If you have a newer scientific calculator or graphing calculator, you actually have the symbols, minutes, and seconds in your graphing calculator and your scientific calculators, and the calculators will automatically convert for you as well. All right, but if I ask you guys to show your work, you're just going to do it this way. This is the conversion from minutes and seconds all into degrees there. Okay, so let's practice. We've got a couple of examples that we want to convert into a decimal form that we can actually use. Now, I won't ask you guys to go backwards. I won't give you guys a decimal degree value and ask you to convert that into minutes and seconds. That gets a little bit more complicated. But all we're going to do is type this into a calculator. We've got our full set of degrees here, 236. To that, we're going to add 14 over 60 and then 15 seconds over 3,600. So if you just take a second, type all of that into your calculator, our final answer here should be something like 236 degrees and 0.24, sorry, 236.24 degrees. All right, similarly, we've got the second example, 1,236 degrees and 59 minutes. We've got our whole set of degrees here, and to that, we're going to add 59 over 60 in order to get 1,236.98 degrees. Right, pretty quick conversion. You just have to remember you divide minutes by 60 and seconds by 3,600 in order to get your decimal values there. Short history lesson, the Babylonians were the ones who decided on the base 60, and they were the ones that determined 360 degrees was a circle. So fun historical fact there. All right, so if you turn the page over in your student note packet to page 3 at the very top, the second way that we're going to measure angles is in radians. So we will be switching between degrees and radians a lot. Those are the only two measures we're going to be using in order to express angle measures. But the word radian comes from the word radius, if we think about what we know about that word from geometry. All right, and a radian is not actually a real unit of measure, but it's actually a ratio of the arc length of a circle over the length of the radius of that circle. So it changes depending on the size of the circle, and so that's why we use what we call the unit circle, a circle with a radius of 1, because radians change depending on the sizes of your circle. So we're going to stick with the unit circle in trig, which means we're going to deal with a radius of 1 as a circle. A radian measure then has no units, no real units, which is why I say it's really important to use the degree symbol for degrees, because if we've got radians, we're not going to have anything that comes after that. Sometimes I'll write rads after a number to express radians, but if you just give a number like that, we're going to assume that's radians, and 2 degrees must have the degree symbol in order to be expressed as degrees instead. Okay, so how does radians and degrees relate? Well, remember, 1 revolution or 1 full circle is 360 degrees. We call that 2 pi radians. So 360 degrees, 1 full circle is 2 pi radians. A half a revolution, we call that straight angle, 180 degrees. That is pi radians then. So the negative x-axis is pi radians. And we'll see that when we look at the unit circle in a couple of lectures. Okay, so we want to convert between degrees and radians. The first set of problems we're going to do is converting degrees to radians, and then we'll go backwards in just a minute. I'll do some of these with you guys, and then I'll have you guys do some on your own before I give you the answers. Okay, so we want to convert the following degree measurements to radians. Now we're going to use what we know about radians, and then we'll come up with kind of an easier way to convert in just a minute. Okay, so let's think of it this way first. I'm going to approach it differently first, and then I'll give you guys an easier way to convert in a minute. 30 degrees. What do we know about 30 degrees? Well, 30 degrees out of 360 degrees, which is a full circle, if I were to simplify this, that's 1/12. All right, so 30 degrees is 1/12 of a circle. Okay, so what do we know? Well, I know that a full circle in radians is 2 pi radians. So if I take 2 pi, a full circle, and I divide it by 12, because 30 degrees is 1/12 of the circle, then in radians, when I simplify, 30 degrees is pi over 6 radians. I'm just giving you guys a different way to think about this before I actually give you an equation that converts easily. If we look at 45 degrees, well, 45 degrees out of an entire circle is 1/8 of a circle. So go back to what we just did. I know a full circle is 2 pi radians. If I divide that by 8 and simplify, 45 degrees is pi over 4 radians. All right, I'm going to let you guys do C in a minute. If I'm looking at negative 240 degrees, well, let's think about it in terms of what we know. Negative 240 is equal to negative 8 times 30 degrees. Now, something really nice. Right above this, we already figured out what 30 degrees was in radians. We found 30 degrees was pi over 6. So I can just take negative 8 and multiply it by pi over 6 radians, and then simplify. Negative 240 degrees is just negative 4 pi over 3. I'm going to have you guys do that for E in just a minute as well. But last one, 180 degrees. Well, 180 degrees is half of a circle. So 2 pi, a full circle in radians divided by 2. 180 degrees is just pi radians there. Okay, take a second, pause the video, and try doing C and E similar to the way that I just did the other 4 examples here, and then check your answers. All right, C, 90 degrees is 1/4 of a circle, so 2 pi over 4 simplifies to pi over 2 radians. And then E, I can represent negative 330 as negative 11 times 30. We know 30 degrees is pi over 6, so negative 11 times pi over 6 gets us a total of negative 11 pi over 6 radians. All right, how about going backwards though? What if I give you guys radian measures and I'm asking for the degrees? Well, let's think about this in terms of kind of how we approached the last couple of examples. We were able to determine some of the radian measures for special angles on the unit circle, so we're going to use those to go backwards here. So 5 pi over 4, that's the same thing as saying 5 times pi over 4, and we found that pi over 4 was 45 degrees. So this is just 5 times 45 degrees, which is 225 degrees. So 5 pi over 4 is 225 degrees. All right, negative 7 pi over 6, well, that's just negative 7 times pi over 6, Well, pi over 6 we found was 30 degrees, so that's just negative 7 times 30, which is negative 210 degrees. I'll skip I, have you guys come back to that in just a minute. If I'm looking at negative 6 pi, well, that's just negative 6 times pi, but we know pi is 180 degrees. So we're just multiplying negative 6 by 180. That's going to give us negative 1,080 degrees. Remember that we're marking degrees with degree symbols. We always want to make sure that we include degree symbols when we're dealing with degrees. If you leave the degree symbol off, I'll assume that you're writing it as a radian instead. So those are very different things. Okay, how about K? The last one I'll do with you guys. This is negative 11 times pi over 6. Well, we actually already converted that in example E right above that. But if I'm going to approach it this way, this is negative 11 times 30 degrees. Pi over 6 is 30 degrees. And that's something, hopefully, that we just have memorized at least by the end of this unit. So this is in total negative 330 degrees. Go ahead and give L and I a shot on your own and then come back and check the answers. All right, for I, these are a little trickier. It's 4 times pi over 3 or 8 times pi over 6. Now, we know pi over 6. We haven't talked about pi over 3. It's 60 degrees. But 8 times pi over 6 or 8 times 30 degrees is 240. That's I. And then L, same thing. Negative 5 pi over 3 is the same thing as saying negative 10 times pi over 6. So negative 10 times 30 is negative 300 degrees. Okay, so breaking up a smaller angle into whatever piece of a full circle it is one way to convert between degrees and radians. But there's an easier way to go. We actually have a conversion. If we can remember that, it'll just make converting between degrees and radians a little bit easier. So it's very similar to how we would approach converting 3 feet into inches, right? Every foot is 12 inches, and we can use that conversion in order to convert between feet and inches. The same is going to be said for radians and degrees. So if we can remember this conversion, it's going to be a little bit easier. So to convert between degrees and radians, we just multiply the degrees by pi over 180. The way that I remember this is pi radians is 180 degrees. So that's something we're going to just have that memorized by the end of this unit. But if I multiply degrees on the top and then degrees on the bottom, the degrees cancel out and we're left with radians. So that's how I remember if it's pi over 180 or 180 over pi. So when we want to turn radians into degrees, we just flip that. We'll multiply the radians by 180 degrees over pi. And what we're left with then is degrees, because the radians will cancel on the top and the bottom. So let's practice this. Let's convert some of these uglier degrees into radians and radians into degrees. So 247 degrees, well, we're just going to multiply that by pi radians over 180 degrees. All right, and the degrees will cancel on the top and the bottom, and that's how I know I'm left with radians. That's how I know I've got the right conversion here. So 247 over pi over 180. If you just type that into a calculator, it's 4.31 radians. All right, on your student note packet, these are a little bit out of order. So that's actually the last one on your student note packet. All right, how about 11 pi over 13? That's not a nice angle. We'll see that. That's not an angle that's going to show up on the unit circle. I want to convert this from radians right now into degrees. So we're going to multiply by 180 over pi. Now the pi's are going to cancel. We're left with degrees, that unit in the top. And then I'm just going to simplify here. So 11 pi over 13 times 180 over pi. If I type that into a calculator, we're in 152.31 degrees. Right? Don't forget your degree symbol there. Okay, so 2.18. Now, this is radians. We don't have a degree symbol here. We want to actually turn it into a degree. So that's why the symbols matter here. We want to make sure that our units are always correct. So 2.18 radians is what we're going to convert into degrees. So to convert radians into a degree, I'm going to multiply by 180 over pi. Okay, so we're left with degrees in the top. You're just going to type this into a calculator and see what you get. 124.90 degrees should be our answer here. All right, the very last thing we're going to do is we're going to draw each of these angles in standard position. And I think this is typically the hardest thing for people, is drawing angles that are given in radian measures. So I'm going to divide the circles kind of into like pies or like slices of pizza and then count out that way, eventually you might not have to do that. You might just be able to get really good at drawing angles and radian measures and be fine. All right, but I'm going to approach it this way. So 2 pi over 3 is what we are drawing. Now remember that a full circle is 2 pi radians. Okay, so 1 full circle is 2 pi radians. If I want to turn 2 pi into something that has the same denominator as the angle we're drawing, 2 pi is the same thing as saying 6 pi's over 3. All right, so 2 pi unsimplified is 6 pi over 3. I'm picking this number because it has the same denominator as 2 pi over 3, the angle that we're actually trying to draw. So 6 pi over 3, I'm going to re-represent as 6 times pi over 3. So if I take this full circle and I divide it into 6 pizza slices, each of those pizza slices will be an angle measure of pi over 3, right? So take this circle, I'm going to divide it into 6 pizza slices. Let's see. That's 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. Okay, and each of those pizza slices represents pi over 3 radians. Now, what angle we're trying to draw here is 2 pi over 3. So I need 2 pi's over 3. 2 pi's over 3 is this angle right here. Okay. Another way we could approach this is we could turn 2 pi over 3 into degrees and then go from there. So remember the conversion, 2 pi over 3, if I multiply that by 180 over pi and then simplify it out, we get 120 degrees. So you're also graphing 120 degrees. If you like to turn everything into degrees and not deal with the radians, it's fine. But it's always really good to know how to graph things with radians. All right, let's try this again. 5 pi over 6. I'm going to do the same thing. 5 pi over 6. Let's talk about the full circle. So full circle is 2 pi radians. If I'm trying to get 2 pi into something with a denominator of 6, that is going to be 12 pi over 6. Okay, so if I divide this circle into 12 even pizza slices, each representing pi over 6 radians, then I can count out 5 of them. All right, so my full circle needs to be divided into 12 even pizza slices. Let me do that, and I'll be right back. Okay, I've got my 12 pizza slices, and we are counting out 5 of those. We need 5 pi's over 6. So 1, 2, 3, 4, 5 pi's over 6 gets me out here at this angle. And 5 pi over 6, positive 5 pi over 6 looks like that. Again, you could have turned that into degrees. 5 pi over 6, it's 5 times 30, or 150 degrees. And then you could have just drawn the 150 degree angle. Negative 3 pi over 4 is next. So again, I'm going to take 2 pi, my full circle, and I want to express it with a denominator of 4 this time. So 2 pi is the same thing as saying 8 pi's over 4. So if I divide this circle into 8 even sections, each section will be pi over 4 radians, and then I will count out negative 3 of those. So we'll get to that in just a minute. Let me divide this circle up first. Okay, so I've got my 8 even pizza slices here. Each of those pieces are worth pi over 4 radians. Now I'm counting out negative 3 of those. So when I'm going negative 3 here, we're going to start on the positive x-axis. This time I'm going to count 3 going clockwise. So 1, 2, 3, negative 3 pi over 4 puts us at this angle here. Now again, you could have turned that into degrees. Negative 3 pi over 4. Pi over 4 is 45 degrees. So it's just negative 3 times 45 degrees, which is negative 135 degrees. And you could have graphed it that way as well. So stick with what works for you. I do like to kind of describe dividing the circle up just to look at radians a little bit differently. Okay, last one, 20 pi's over 3. So this one's going to have multiple spirals going around because we're graphing something larger than 360. But let's talk about how to get 2 pi into a denominator of 3 first. So 2 pi is the same thing as saying 6 pi's over 3. So if I divide my circle into 6 even pizza slices before I do anything else, we're going to have 6 even sections that are each pi over 3 radians. So there's my 6 even sections. Now, each of those sections are pi over 3 radians. We need to count out 20. So I'm going to start along the positive x-axis and I'm going to count 20 sections. So here we go. Going counterclockwise because it's a positive measure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 pi over 3 is this angle here. And we went around the circle, it's 20 pi over 3, quite a lot, right? So we always express multiple rotations around a circle with all of those kind of spiraling circles there. Now, you could have also chosen to graph it as a degree instead. 20 pi's over 3, well, pi over 3 is 60 degrees, so it's 20 60-degree angles, or 1200 degrees. You could have graphed it like that as well. All right, that is it as far as an intro to angle measures go. Email me if you've got questions. Hopefully that's nothing new. Should be review from Algebra 2, but let me know if you guys need anything.